Okay, bless you. Welcome to Mr. Morrow's Advanced Honors Algebra class. Today, we're going to deviate from the book. You're not going to really find this in the book. You're going to find applications of this in the book, but you're not going to find the actual teachings of this in the book. So that's why I wanted to make sure that we did it together in class. Let's talk about, first of all, in this rates, ratios, and proportion conversions, let's talk about what a ratio is, okay? A ratio is a comparison of two numbers with the same units by division. Okay, sorry about that little interruption there for a second, my bad. Okay, so a ratio is a comparison of two numbers with the same units by division. Now, this whole same units thing is really important, okay? By same units, I mean same units. So the ratio of boys to girls was 3 to 5. 3 boys to 5 girls. Now, you may be saying, it's not the same unit. Boys are different than girls. Yes, but we are the same human. So that's what I mean by the same unit. If I say you have the ratio of A's to C's in the class is 6 to 9. Okay? We're talking about grades, so unit to unit, same unit. There are 3 ways to write ratios. You can simply say A to B. So for example, for the 6 to 9 example, okay, this is 6 to 9. Or you could go 6 colon 9, or you could write it as a fraction 6 to 9. 3 ways to write a ratio. Ratio, remember, is a comparison of numbers, but those numbers have the same kind of units. Now, a rate. A rate is a comparison of two numbers with different units by division. So rates would be something of this nature. Oh, over the weekend I drove 213 miles in 4 hours. Do you see how I have a miles and I have an hours? Are those different units? That's what a rate is. Mr. Morrow can type 112 words in 1.7 minutes. Are those different units? So that's a rate. Does that make sense, boys? Now, a unit rate. A unit rate is a rate with a denominator of 1. Okay? A rate with a denominator of 1. So this is seen very often in your car when you're driving. You're driving and you see the odometer and it starts to increase and you see it at 60. What's happening there is you're going 60 miles per 1 hour. What that means on the odometer is that every hour you're going to go that many miles. That's what is a unit rate. Mr. Morrow can type 58 words per 1 minute. It's a unit rate because the denominator is 1. Mr. Morrow can grade 2 quizzes, which is not true at all, in 1 minute. Okay, it takes me a lot longer than that, but it's a unit rate. Does that make sense, boys? Yes? No? Okay. Now, unit price. Unit price is another unit rate, but it deals with pricing. It's the price of 1 unit of a particular item, and it is found by using the formula price divided by quantity. It's price divided by quantity. This is very useful when you're out shopping, okay? Let's say Mr. Morrow's on a budget, okay? And I don't want to spend a whole bunch of money. I want to try to save some money. So I see 3 cans of tuna. We'll just make the numbers easy. For $3.30. Or I can get 5 cans of tuna for, let's say, $6. Okay? Believe it or not, Mr. Moore will calculate this. He will. because I want to save money. I want to know how much am I paying for one can. I'm looking for the unit price. Okay? So unit price is price divided by quantity. So for this first example, I got $3.30 divided by 3. So that means I'm paying $1.10 per one can. See how it's a unit rate because it's a denominator of 1? So I'm paying $1.10 per can. Over here, $6 divided by 5, that's going to be 1.2. So that's going to be $1.20 per one can. That's a unit rate. So unit rate and unit price are the same, except unit price is always price divided by quantity. Whenever you're talking about a unit rate or a unit price, you want a 1 on the denominator. Does that make sense so far? Yes? No? Maybe kind of, sort of? Okay. Proportions. Proportions are equal ratios. They have the same value with different appearances. How do you know if two ratios are proportional? Well, if you cross multiply them and compare their cross products, if the cross products are equal, they are proportional. For example, 7/6, is that proportional to 14/12? Well, a couple ways to do this. First of all, what's 12 times 7? 84. Got to sharpen up your math skills, guys. What's 6 times 14? 84. Are they the same cross products? So these are proportional. They are. Because they are the same value, different appearance. Now, sometimes you can see the relationship without having to cross multiply it. For example, my brothers, what did I multiply to 7 to get to 21? What's 6 times 3? 18, right? So are they equal? Yes. Are they proportional? Yes. That makes sense. Promise? Awesome. All right. Now, let's get into some application. Okay. Using rates and ratios and proportions, all that good stuff, we have something very important called conversions. Sometimes you have to convert from one unit of measurement to another unit of measurement, okay? And you're going to do that by using what's called a conversion factor. Now, I want to show you the easy way and the little bit tougher way, okay? It's pretty much both the same things, but there's an easy way and a little bit of an easier way. This right here, this remember the following, that's the easy way, bud. When going from larger unit to smaller unit, multiply by the conversion factor. When going from a smaller unit to a larger unit, you divide by the conversion factor. Let me explain what I'm talking about. For example, if I give you 36 inches equals how many feet? Guys, first of all, am I going from inches? I'm going from small to large or large to small? Small to large. So am I going to multiply or divide? Am I going to multiply or divide? It's right there in front of you in the screen. I'm going from small to large. Am I going to multiply or divide? I'm going to divide. Smaller to larger, divide. Now, what am I dividing by? What is the conversion factor? How many inches in 1 foot? 12. So 36 inches divided by 12 inches gives you 3 feet. Now that's the easy way. Okay? Now, some people, like Mr. Morrow when I was a kid, didn't get it that way. I didn't understand. So I created a different way. And this is what I did. Whenever you have a conversion, you're going to be using this conversion factor, correct? That's the fact. So what I always did was I set up a proportion. My fact ratio, I called it, my fact ratio. What is the fact ratio that we know about inches and feet? What fact do we know about inches and feet? Guys, what fact do we know about inches and feet? So the fact ratio is that 12 inches is in 1 foot. Does everyone understand what the fact ratio is? That is the fact that you know about the conversion. That is the conversion factor. Does that part make sense so far? Now, when you're setting up a proportion, please remember unit to unit. Okay? Like unit to like unit. How many inches was I given in our example? Inches to inches. So inches on top. Do you see what I mean by unit to unit? Inches to inches? How many feet was I given? X. I calculated 3, guys, but I was given X. Unit to unit. You feel me? Now, you can go ahead and cross multiply. X times 12 is 12x, which equals 36 divided by 12. You know how to solve a single step equation. X equals 3 feet, because that's what I was looking for. Done. I did nothing differently except use a lot more time for this one. But it's exactly the same thing. I don't care which one you use. All I care about is whether or not you understand it. Yes, sir. You sure, my man? Okay. Thank you. You okay, Bob? Thank you. Are we good so far? All right. Now, in order for you, I don't expect you to write this down immediately. This is the kind of things that you want to write down at home, taking your time. I don't want you to rush through it. I will explain it to you right now, but you need to memorize these if you don't know them yet. Okay, my brothers? You got to. It's just, you got to. I'm sorry. We've got the English system of measurements. English system is different than the metric system, okay? The English system, we use inches and feet and yards and miles and gallons and all that good stuff. We have to know how to relate them. We have to know the fact ratios. There's 12 inches in a foot. There's 3 feet in a yard. There's 5,280 feet in a mile. I'm going to go ahead and add a couple. There's 1,760 feet. I'm sorry. Stupid. Bad, Mr. Morrow. 1,760 yards in 1 mile. And also, there are 36 inches in 1 yard. You could have calculated that on your own, but those are pretty popular. Weight is really nice and easy. 16 ounces in a pound, 2,000 pounds in a ton. Done. Now, capacity. Capacity is volume, guys. Okay? It's how much space something takes up. It's usually liquid measures. You know, when your mom is cooking or your dad is cooking or you're cooking or you're baking something, you know, 2 cups of margarine, 3 cups of milk, 1/4 cup of sugar. Okay, these are all capacities. 3 teaspoons equals 1 tablespoon. 16 tablespoons equals a cup. 8 ounces, fluid ounces, I'm going to put a little FL there because it's fluid ounces in 1 cup. 2 cups in a pint, 2 pints in a quart, 4 quarts in a gallon. Okay? These are really, really, really important for you to memorize. Not for Mr. Morrow, but for SATs, for tests, for quizzes, just for general knowledge in life. You want to be able to know these things, okay? Does that make sense, gentlemen? Okay, thank you, my brothers. Remember, if you didn't get a chance to write it all down, that's why we have a video. Okay, now the 3 basic units of the metric system are the meter, the gram, and the liter. This is metric now, okay, metric. The gram is weight, the meter is length, and the liter is capacity or volume, okay, volume. Now, look at what we got here. The basic unit is a value of 1. That's 1 whole unit. Meter, which is distinguished as a little m. Gram, which is a little g. And L, which is a capital, liter, which is a capital L. Okay? So when I have kilo, kilo is capital K. So I can have kilometer, kilogram, or kiloliter. Okay? And actually, you don't have to put a capital, just the regular K. Don't do a capital. That's stupid of me. I'm sorry. Hecto. Excuse me. H. Hectometer, hectogram, hectoliter. Deca. DA. Decameter, decagram, decaliter. Meter, gram, liter, it's one whole. Deci, decimeter, decigram, deciliter. Centi, centimeter, centigram, centiliter. Milli, milligram, milliliter, millimeter. Please do not get confused with milli and M for meter, okay? Milli will have something attached to it. Milligram, milliliter, millimeter. If it's just the M by itself, it's just meter. And just so you know, a millimeter is about the thickness of a dime, roughly. Okay? Now, as far as conversions go, there's the easy way and the hard way, all right? It's kind of strange. I don't like the way that most people teach this, so I came up with my own method, and I think it's a lot easier. I'm going to explain that now in the next slide, okay? Now, whoa, that's kind of hard to read. Sorry about that. Should have made that a little bit bigger. Let's see if I can help you guys out with this. Let's try to make it a little bit bigger. I apologize. That doesn't really make it that much better. Well, a little bit better. Sorry, guys. You're gonna have to focus when you're doing these notes. Okay. Well, the metric measures. A kilometer, because remember we're dealing with King Henry died. Unfortunately, that's the unit. Drinking chocolate milk. King Henry died. Unfortunately, drinking chocolate milk. Good way to remember that. Okay. So now, and I don't know if you guys noticed on the last slide they had 1,000 here. At 100, they had a 10, a 1, a 0.1, a 0.01, and a 1,000ths. 1 kilometer is 1,000 meters. That's what this means. 1 hectometer is 100 meters. 1 decameter is 10 meters. 1 meter is 1 meter. A decimeter is 1/10 of a meter. Centimeter is 1/100th of a meter. Millimeter is 1/1000th of a meter. Okay? So, the way they do it is as follows. Okay? If I have 3 kilograms, and I want to know how many grams that is, this gets very, very confusing in my opinion, this first way I'm going to teach it. Since I have 1,000 grams in 1 kilogram, right? Kilograms are larger than grams, correct? Right? So now, that's where it gets a little bit confusing. It's not the same as our conversions with the English system. We had said that when it's going from large to small, you actually, no, you do multiply. Yeah. What's wrong with me? Yes, it is the same, of course. You're going large to small, so you multiply. How many grams are there in a kilogram? 1,000, right? So 3 times 1,000 would equal 3,000 grams. If I had, for example, 12 grams and I want to know how many milligrams that would be, am I going small to large or large to small? I'm going large to small. So I'm going to multiply or divide. I'm going large to small. So I'm going to multiply, right? Okay, now I got 1, 2, 3. There's 0.001. So I'm going to multiply by 100. I'm going to multiply by 100 in this way. So this is going to be 1,200 milligrams. Now, by the look at your faces, you're giving me the same faces that I used to give my teachers when they were teaching it this way. 12. It's what? Yes, it is. 12,000. My bad. 3 zeros. 12,000. Now, I hate this way. You have to ask too many questions. Do I multiply? Do I divide? When do I divide? Too crazy. So I don't really like this method. If you like it, great. God bless you. I like the second method better. The second method is a matter of moving your decimals. Okay? I've got, again, King Henry died, unfortunately, drinking chocolate milk. Now, check this out, guys. The second method, it says to locate the first spot that you're starting with. Then find the next place that you're going to. Then just simply move the decimals left or right as many spaces as it takes to get to the next spot. So, for example, if I have 3.8 milligrams, and I want to know how many grams. Okay, where is milligrams? Right, it's right here. Perfect. Where am I going? To the middle, to the unit. So am I not going 1, 2, 3 to the left? So I go 1, 2, 3 to the left. It's going to be 0.0038 grams. Tell me that isn't boss. That's pretty good, right? Now, could you have done it the other way, Mr. Morrow? Of course. Am I going small to large or large to small? I'm going small to large, so then do I multiply or divide? So if I divided 3.8 divided by 0.001, I got to move the decimal 3 places to the left. Either way, I'm doing it. Does that make sense? So if I gave you, for example, 16 meters, and I want to know how many kilometers it is, where am I starting in this particular case, boys? Where am I starting? I'm at meters, I'm at unit. Great job, boys. Great job. I'm at meter, I'm at units. Where am I going? Heck yeah. 1, 2, 3 to the left. 1, 2, 3 to the left. 0.016 kilometers. Seriously, no sarcasm. Does that make sense? It's pretty awesome, right? Just go by your decimals. Or, like I said, you can ask yourself the questions, but this takes a lot less time, in my opinion. That make sense, boys? Awesome. All right. Now, let's practice. Let's just do some practice of everything that we've done. Because believe it or not, we did a lot today. Most people can't handle the amount of stuff that we just did today, but you guys do handle it because you're bosses. You are shopping for T-shirts. Which store offers the best deal? They're looking for a unit price here. What's the formula when we're finding unit price? Price over quantity, right? We're looking for the denominator of 1, but how do we get it? We got to divide it first. So here, what's the unit price for store A? 25 divided by 2. That's $12.50 per shirt. What is the price for store B? 45 divided by 4. Don't worry, just do it out here. It's going to be 1, 4, 5, 1. That's 4. Decimal, decimal, 1, 2. Whoever said that is correct. 11.25 is exactly right. So that's $11.25 per one shirt. What is store C? Okay, for store 3, it's price 30 over quantity of 3 shirts. So that's $10 per one shirt. So if you were at a mall or something and they had all of these deals, which would be the best deal? Absolutely right. Does that make sense? Okay? All right. Now, let's convert each. 330 minutes to hours. First of all, I'm going small to large or large to small? Going small to large, right? So I'm going to divide, right? By, because there's 60 minutes in 1 hour, right? So you go 330 divided by 60. Cancel that out. So that's going to be 5 12.5 hours. 150 kilograms to grams. Whenever this happens, do what Morrow does. King Henry died, unit, drinking, chocolate, milk. I'm at kilograms. I'm going to grams, which is here in the center. 1, 2, 3 to the right. 1, 2, 3 to the right. Boom. 15,000 grams. So it makes sense, boys. Okay. 11 pounds to ounces. How many pounds in an ounce, first of all? 16. Am I going large, small, or small or large? Well, yeah, I had a little bit of both. Large to small. So I'm going to multiply or divide? I'm going to multiply. 11 times 16 is 176. Yeah, there's 16 ounces in a pound. No. It's 16 ounces in 1 pound. So therefore, I went from large to small, guys. Large to small, so I multiplied. So 17 times 11, I promise. Why 17? Because I'm stupid. Okay, because I'm dumb. Okay, 6 and then 1, so that is 176 ounces. Okay. 5 feet 3 inches. How many total inches is that going to be? Oh, 63. Fantastic. 5 feet. 5 times 12. Why times? Because I'm going large to small. 60 plus 3 is 63 inches. Boom. Perfect. 1,250 centimeters to meters. Remember, King Henry died, unfortunately, drinking chocolate milk. Where am I starting? At the centimeter. Where am I going? 1, 2 to the left. 1, 2 to the left. 12.5 centimeters. Maybe I should learn how to pay attention. Thank you, son. Great job, son. So that's 12.5 meters. Pay attention, Morrow. 6 hours, 45 minutes into hours. Three-fourths, very good. All right, guys, we got to 6 hours. I like that. I like that you guys are thinking. I'm very proud of you. 45 minutes, so I'm going minutes to hours. Do I multiply or divide? I'm going small or large, so I divide. So 45 divided by 60 divided by 15 divided by 15 is 3/4. So this is 6 3/4 of an hour, or 6.75 hours. Does that make sense, my brothers? Yeah. Promise? I'm sorry, my man? Or. Either or, Baba. Thank you. All right. Now. Now we get to some good stuff. The CN Tower in Toronto, Canada is about 1,815 feet tall. About how many meters tall is the tower? Use the fact that 1 meter is about 3.28 feet. So we could do this logically, and I'm going to also set it up with a proportion because I don't want you guys to stress. From what they gave us, I'm going from feet to meters. So am I going from large to small or small to large? Small to large, because if you notice, 1 meter is 3.28 feet, correct? So I'm going small to large. I got to divide, right? Okay, I am going to cheat today. You are not allowed to cheat, but I'm going to cheat. I'm going to divide using my calculator. I earned it. Get a degree, and then you can too. I love you guys. You guys are the best. So, no, seriously, just save time. When I divide this, 1,850 divided by 3.28, that's going to give me roughly about 553. We'll just leave it like that. We won't put the decimal. 553 meters, roughly. Now, you could have done it another way. Give me 1 second, my man. You could have just straight up said, okay, let's set up a fact ratio. The fact ratio is that there are 3.28 feet in 1 meter. Correct, my brothers? They want to know how many meters in 1,815 feet. Do you guys see how I set that up as well? Unit to unit using the fact ratio. This is the fact ratio right here, my brothers. And then unit to unit, were you with me? If you cross divide here, I promise you, X is still going to be roughly 553 meters. You got a question, sir? You sure, my man? Thank you, sir. Does that make sense, boys? Pretty easy, right? Okay? No, this is not on Friday's test. No, I repeat, this is not on this Friday's test. I just started this with you. We're going to have a homework on this. You're going to have quizzes on this, but that wouldn't be fair. Friday's test is on all of Chapter 1, 1.1 to 1.6. And it's already stuff that you already know how to do, so I suggest you study a lot to make sure you guys get that good grade so we can replace the lowest grade you've had, right? We're gonna kick it out, right? All right, I believe in you. I'm proud of you guys. Okay, how about this? A student ran 50-yard dash in 5.8 seconds. At what speed did the student run in miles per hour? Uh-oh. Okay, so look at what happens here. I have 50 yards over 5.8 seconds. I need to convert each of these first to miles per hour, guys. So don't stress your lives out. Don't stress. I'm going from yards to miles, right? Because I need miles over hours, right, my brothers? So I'm going yards to miles. Is that multiplication or division? I'm going from small to large, right? We already said there's 1,780 yards in 1 mile, correct? So am I going to multiply that to 50 or divide it by 50? Divide. I'm going small to large or divide. So I'm going to use my nifty calculator. 50 divided by 1,780. So that's going to equal roughly 0.028 miles. Now, how many seconds are in an hour? Yes, ma'am. Okay. So, I'm going, how many seconds in an hour? No, that's how many minutes in an hour, my brothers. It's 3,600, okay? There's 3,600 seconds in an hour. So I'm going seconds to hours. Is that small to large or large to small? Small to large, I'm going from seconds to hours. So I'm going to divide. So 5.8 divided by 3,600 equals 0.0016. Now, 0.028 divided by 0.0016 equals 17.5 miles per 1 hour. If I gave you something so complicated like this, guys, you are allowed to use the calculator. On your homework, if you see something like this, I'm not here to torture you. You may use the calculator. On my test, I'll make it numbers that you don't need a calculator. But on your homework, I don't want you to spend hours and hours just multiplying for a decimal, guys. So you may use a calculator, okay? May God bless you and have a wonderful day. Thank you.